Hi, Vintage Stereo Buff here. Today I'm going to do something a little different. I'm going to dyno test two different amplifiers at the same time. And one is a Special Edition Electronics A275. It's made by PPI for Philips. This 275 is two channels at 75 watts per channel into 4 ohms. And then the other one is the Proton D275. It's also rated at 2 times 75 watts into 4 ohms. Or bridged in, it'd be 150 bridged into 8 ohms. And this one would be 150 bridged into 8 ohms. I'm not sure what the 2 ohm per channel rating is or the 4 ohm bridge rating is on either one. I guess we'll find out. Theoretically, some of these amps are supposed to double their power when you reduce the impedance halfway, but that's theoretically. What I've found is that it doesn't always work out in reality. Anyway, we'll get started. Hi, Vintage Stereo Buff here. I have my Special Edition Electronics A275 hooked up. The first test I'm going to do is at 8 ohms, 40 hertz. It's bridged into 8 ohms. I'm going to do a 40 hertz continuous power test up to 1%. Here's my distortion light right here, and I'm going to read the power off of this meter here. We'll get it to dyno mode. Okay, turn it on. I think I'll zoom it in a little bit so you can see the thing a little better. Okay, I should be ready. $161 watts at 7.9 ohms. I have it hooked up into 8 ohms bridged mode. I'm going to do a continuous power test on it with a 40 hertz tone. Let me zoom in a little bit so you can see the meters better. Turn the meters on. I'll put it on dyno mode. So we'll lock on the number. I'm going to run it up to 1% distortion when this little light blinks on. Okay, here we go. $148 watts. I have my Special Edition Electronics A275 hooked up. It's bridged into 4 ohm load. I'm going to do a 40 hertz continuous power test. Here's my meter to measure the power. This is 1% distortion. I'll zoom it in a little bit so you can see the meter a little better. Okay. Okay, now I'm going to test my Proton D275 with a 40 Hertz continuous tone into a 4 ohm load. Next I have my special edition electronics A275. I have it bridged into 4 ohms and I'm going to do a 40 Hertz dynamic burst test. Here's the meter right here. Try to zoom it in a little bit. Okay. $340 watts into 4 ohms. Okay. Now I'm going to do a 40 Hertz dynamic burst test into 4 ohms. I'll zoom in my lens a little bit so you can see the meter better. Okay. $364 watts at 3.9 ohms. Hi, Vintage Stereo Buff here. I have my special edition electronics A275 bridged into 8 ohm load and I'm going to do a dynamic power test. Here's my meter to read the power. Here's a 1%. Well, I'm turning it off. I'm going to run it up to clipping. I'll zoom it in a little bit so you can see the meter a little better. Okay. $180 watts into cupping. Okay, for my final test, it's going to be bridged into 8 ohms dynamic burst test, 40 Hertz. This is where this amp should really kick ass. 631 watts into 675 into 8 ohms. Yep. Well, as you can see, they ran pretty close together in the continuous power measurements. They were pretty close. But on the dynamic power measurements, the Proton did much better, especially in the 8 ohm section. It did, in 8 ohm tests, the Proton put out 4 times as much dynamic power as it did continuous. That's the dynamic power on demand circuitry. It obviously works. Well, now that you've seen the results of the tests, you see that on most of the tests, the amps actually were pretty close together. Maybe one measurement I think was about 24 watts difference, which is not really very much. You'd never notice a volume difference of 24 watts. But now you can see why the dynamic power is so much better on the Proton. Here are the caps in it. This one just has the 2200 microfarad cap, and that's not even a rail cap, that's a filter cap. These 2 rail caps are 1000 microfarad 50 volt caps. And those are the main power caps. Now on here, it operates most of the time on these 2, and they're both, these are both 2200 microfarad caps. 2200 microfarad, I think they're 85 volt caps. And then these others, these were made specifically by Proton. You can see the Proton label down there. But they were made by Nichicon, which makes very good capacitors. And those are proprietary capacitors, and from what I understood, they're very hard to find to do any repair. Anyway, I hope you enjoyed the test. And if you like these videos, push the like button. And I would like to have some comments, positive or negative or whatever, or maybe some suggestions for other videos. For now, Vintage Stereo Buff out.